When do converses prove parallel lines with transversals? Imagine you're looking at two lines crossing a third line, called a transversal. How can you tell if those two lines are actually parallel? That's where the idea of converses in geometry comes into play. In geometry, we know that if two lines are parallel, certain angle relationships happen when a transversal cuts through them. For example, alternate interior angles are equal, and corresponding angles are equal. These are called theorems. But what if you see those angles and want to prove the lines are parallel? That's when the converses of these theorems come into action. The converse of the alternate interior angles theorem says, if two lines are cut by a transversal and the alternate interior angles are equal, then those lines must be parallel. So, if you measure and find that angle 3 equals angle 7, you can conclude the lines are parallel. Similarly, the converse of the alternate exterior angles theorem states, if the alternate exterior angles are equal, then the lines are parallel. For instance, if angle 1 equals angle 5, then the lines are parallel. The converse of the corresponding angles postulate is also important. It says, if the corresponding angles are equal, then the lines are parallel. So, when you see that angle 2 matches angle 6, you can say the lines are parallel. Lastly, there's the converse of the consecutive interior angles theorem, which is a little different. It says, if the two angles on the same side of the transversal inside the lines add up to 180 degrees, then the lines are parallel. If you find that angles 4 and 5 are supplementary, then you know the lines are parallel. In practice, you start by identifying the transversal crossing the two lines. Then, measure or observe the angles formed. If the angles meet the conditions of the converse theorems, being equal or supplementary, you can confidently say the lines are parallel. These converses are powerful tools because they turn angle relationships into proof of parallel lines. They help you analyze complex figures by breaking them down into simple angle comparisons. Knowing when and how to use these converses makes solving geometry problems much easier and more straightforward. So, next time you see a transversal cutting through two lines, remember, if the angles are congruent or supplementary in the right way, you can use the converse theorems to prove those lines are parallel.